Assalamu alaikum friends, welcome to my channel MBBS and BDS lectures. Today our topic is related to local anesthesia, mechanism of action of local anesthesia. Before going to explanation, if you want to watch the same lecture in Urdu Hindi, I already upload the same lecture in Urdu Hindi on my YouTube channel. Go and watch that video. But if you want to watch in English language, then this video is for you. Now today topic is mechanism of action of local anesthesia. First we will understand the mechanism of action of local anesthesia from two diagrams. At the end we will study the steps of local mechanism of action of local anesthesia. First, this is the diagram of neuron. Now this is the cell membrane of neuron. In cell membrane of neuron there is a voltage gated sodium ion channel. Now this voltage gated sodium ion channel have two gates. One is outer gate, this is outer gate, and second is inner gate. These are the two gates of voltage gated sodium ion channel. Now in normal condition, the outer gate of sodium ion channel is closed and the inner gate is open. This is the normal condition. But when stimulus is present, in the presence of stimulus, the outer gate become open and sodium ion move inward and inner gate is already open. When outer gate become open, sodium ion move inward and inner gate is already open. In the result, there will be depolarization inside the cell. When depolarization inside the cell occurs, in the result there will be action potential. And due to action potential, there will be impulse conduction. And at the end, the stimulus will reach to the impulse will reach to the brain, and we feel pain due to that stimulus. This is the stimulated condition. Now, in case of local anesthesia, when we inject local anesthesia, from injected site, local anesthesia diffuse through lipid bilayer of cell membrane and come to the exoplasm in cytoplasm of neuron. When local anesthesia molecule come to the cytoplasm of neuron, in the inner side of sodium ion channel, there is a receptor. On that receptor, the calcium ion is present. Now, why on that receptor calcium ion is present? Because through calcium ion channel, the permeability of sodium ion is controlled by calcium ion through this receptor. Now, when we inject the local anesthesia molecule, when local anesthesia molecule diffuse through lipid bilayer and come to the inner side of sodium ion channel, and local anesthetic molecule displace this calcium ion and come to this receptor on which already calcium ion is present. Now local anesthesia displace the calcium ion and local anesthetic molecule will be attached on this receptor. When local anesthetic molecule attach on this receptor, in result there will be closing of inner gate. When due to receptor attachment, the inner gate of the sodium ion channel become closed. When inner gate become closed, then when stimulus is present, in the presence of stimulus, outer gate become open, sodium ion move inward, but inner gate, due to local anesthetic, inner gate is closed. The sodium ion will not move inside the cell. When sodium ion not move inside the cell, in the result there will be no depolarization. When there is no depolarization, there will be no action potential. When there is no action potential, there will be no impulse generation. When there is no impulse generation, in the result there will be no impulse conduction, and in the result there will be no pain. This is the mechanism of action of local anesthetic. Now, again we revise the same diagram once again. This is the sodium ion channel, voltage gated sodium ion channel in the cell membrane of neuron. Sodium ion channel have outer gate and inner gate. In normal condition, the outer gate is closed and inner gate is open. When stimulus is present, due to stimulus, the outer gate is open and inner gate is already open. Sodium ion move inward. In the result, there will be depolarization, action potential, impulse generation, and impulse conduction. In the result, there will be pain. But when we inject the local anesthetic molecule diffuse through lipid bilayer cell membrane and come to the inner side of sodium ion channel. In the inner side of sodium ion channel, there will be receptor on which calcium ion is present, which regulate the permeability of calcium ion of sodium ion of permeability of sodium ion through sodium ion channel. Now, local anesthetic molecule displays the calcium ion, and on that receptor side, the local anesthetic attach, and in the result, there will be closing of inner gate. When inner gate become closed, when inner gate become closed and stimulus is present, due to stimulus, the outer gate become open and sodium ion move inward, but inner gate is closed. There will be no sodium ion influx, there will be no depolarization, no action potential, no impulse generation, no impulse conduction, no pain. This is the first diagram. Now come to the second diagram, same like first diagram. This is the sodium ion channel, and this is the outer surface of cell which have positive ion, and inner surface of cell, there is the inner side of the cell, there will be more negative ion, and outer side there will be more positive ion. Means cell is polarized. This is positive pole and this is negative pole. This is the voltage gated sodium ion channel. Now in normal condition, the outer gate, this outer gate is closed and the inner gate is open, like here. Outer gate is closed and inner gate is open. Now, second is stimulated condition. When stimuli is present, in the presence of stimuli, the outer gate, this outer gate which already is closed, in the presence of stimulus, the outer gate become open. Now outer gate become open and inner gate is already open. This red inner gate is already open like here, and sodium ion move inward. There will be depolarization, and there will be after depolarization there will be action potential, and after action potential there will be impulse generation, and after impulse generation there will be impulse conduction, and in the result there will be pain like here. But in the case of local anesthetic, when we inject the local anesthetic diffuse from cell membrane and come to the receptor side. This is the receptor side on the inner side of sodium ion channel on which calcium ion is attached. Now local anesthetic displays the calcium ion and itself attached on this receptor, and when local anesthetic attached on this receptor, in the result there will be closing of this inner gate. Here the inner gate is open, but here due to local anesthetic attachment on receptor, the inner gate become closed. When inner gate become closed and painful stimuli is present, sodium ion move inward, but the inner gate is closed. There will be no influx of sodium through sodium ion. There will be no depolarization. There will be no action potential. There will be no impulse generation, and there will be no impulse conduction. In the result, there will be no pain. These two diagrams are same, but here the sodium channel is more prominent. First, we studied the mechanism of action from diagram. Now come to the steps of mechanism of action. In first step, local anesthetic diffuse from perineural space. Perineural space means space around the space. What is perineural space? This is the neuron, and the space around the neuron. This is the perineural space where we inject the local anesthetic. Now, in first step, local anesthetic diffuse from perineural space to exoplasm through lipid bilayer of cell membrane. This is the exoplasm, in cytoplasm of cell membrane. Now, in first step, a local anesthetic diffuse from perineural space, the space around the neuron, and enter into the exoplasm of neuron through lipid bilayer of cell membrane. This is the first. Now, second step, calcium displacement from sodium channel receptor side by local anesthetic. Now, local anesthetic displace the calcium ion from receptor. This is the second step. Calcium displacement from sodium channel receptor side by local anesthetic. Now, in third step, local anesthetic bind to this site. When local anesthetic displace the calcium ion from receptor, then local anesthetic itself attach on this receptor. Now come to the fourth step. When local anesthetic attach on this receptor, what they do? In fourth step, blockade of sodium channel. There will be blockade of sodium channel, mean closing of inner gate and blockade of sodium channel. When sodium channel become blocked, in fifth step, lack of development of action potential, means there will be no action potential because there is no depolarization. In fifth step, lack of development of action potential. In last sixth step, conduction blockade occur. Conduction will be blocked. There will be no impulse conduction through axon because impulse is not generated. This is the steps of mechanism of local anesthesia. Now, today we studied the mechanism of action of local anesthesia through two diagrams and then steps of local anesthesia in detail. Now, today our topic is complete. If you like my video, press the like button and share this video with your friends. If you are new to my channel, subscribe my channel by pressing the red subscribe button and also press the bell icon to open all notifications in order to you receive my each new video notification. For watching my videos, I am very thankful to you. Thank you very much.